All right, so today we have another video, and first of all, I would like to say thank you to all the new people who started to follow us and joined us here, and thank you for all the views we had. I was somewhat surprised that the non-narrated video, which was rather short, like 35-40 seconds, got 37,000 views in just 3 or 4 days, and the narrated ones, which were more, comprehensive and in detail, got only 10 or 20 views. I'm not sure why that is, but well, anyway, if you're interested, you probably want to watch the longer videos. This is just a short update here. I have another video I'm going to post just of the engine starting and running today. And I just want to show you real quick of what I did here and what was wrong with it and how far we got and what else there's to do now. So you can see here the CIS system right here, and the CIS itself here, and the air intake and the airflow meter. And then over here we have the ICV, the idle speed or idle control valve. These are the two rubber boots I changed already. What you see on the picture, this is still the old ICV. I got the new one in today. I will show you that in a second what I got here, but I don't have an updated picture yet. I changed the water temperature, the 4-pin water temperature, which is underneath this plug here. And we changed the EHA. And if you read my stuff, then you know that I said that the previous owner got the machine to run. So the sequence of failure is as follows. The temperature sensor has two, I think, either NTCs or PTCs in there. Negative temperature coefficient or positive temperature coefficient. I can't remember. As lower the temperature is, as higher the resistance is on this one. It is like 10 kilo ohms at around 14 degrees Fahrenheit. And then at 32 Fahrenheit, you got around 5-6 kilo ohms, and then it goes all the way down to 300-400 ohms at like 200 degrees Fahrenheit when the water 212 boiling temperature. Anyway, that thing here was on the way out, and what they started to do, and these two hoses, basically this hose here, any rubber hose you see here in this area in this engine is basically gone. I changed already the fuel hoses on here. These vacuum hoses, you can't even get them off. I took these two off that switch here, and it actually broke on the switch. These are all the original parts. This is a 1989 560 SEL. The manufacturing is March of 1989. So the car is coming up on 32 years in 3 months, basically. And that's how old the parts are. So the first thing that happened is these boots are getting hard. I didn't bring them here. They're so hard you can squeeze them. The new ones, they're like soft rubber. You can squeeze them easily. You can form them. You can put them on there. The only thing I have not changed is that little PVC pipe in here, which is also very hard and very brittle. I got 1 meter of replacement stuff. I just looked in the box, and I have to replace that too for this to seat better and seal better in there. So what they did is, this is where the air started to bypass. That got this whole internal part dirtied up, and it doesn't move anymore. The way this works is there's a spring in there, and that spring pulls that little plastic part back towards the valve body. When the valve is activated electrically, it pushes that plastic thing against that hole here in the front, cutting off the air flow from here, from this side here going through here. There's a small bypass, basically. That's what that is. It's a little tiny bypass. If this bypass leaks, then you're going to get more in there, which will raise your idle speed. This thing goes underneath where the actual air intake is into the engine, and the linkage hooks up to the thing, and your throttle is basically here, the throttle plate, and that's basically where that goes to, and it bypasses this. And that thing alone will regulate your RPM, your idle RPM. So when they want to slow it down, they put a current through it that pushes that thing back, and then it slows down. And now what happens is when you release the current, that spring is supposed to be pushing that plate back into this direction, into the body, and opening up. And when this thing starts to stutter, I will make a different video with this where we can actually see this better. I will show you the valve with the lab power supply of how that actually gets stuck halfway open. So you put a current on it, you release the current to actually open it fully up to get the RPM up, and it starts to hang halfway in between, which means you can't really regulate the speed, and that's where that rough idle is coming from. And I don't know if brake cleaner is going to work better than C-foam or whatever. These things, they just go bad. No matter what chemical you're going to put in there to clean it, it will run into the valve body itself. There's a coil in there, there's an anchor in there, a metal piece. All of the stuff is prone to corrode. And then when that starts to get sticky, then nothing is going to move anymore, and this whole thing basically seizes up. So this is something which has to be replaced. And then, so what they did was, when this started, is for one is there's a clamp on here which they removed, and the clamp, as you can see, is one of these little body things here. That thing is hot, totally hot too. So it screws into the bottom here, and then on top the shell, the clamp is going to attach to this. It is usually has the same metal piece here on top with a nut. I think it's a 10 M10. You need a 10 socket for it, and it clamps it to it. When you clamp this, when these hoses are hot, the thing will suck air by in every direction. You never get any idle going. So what they did is they just removed the whole clamp to have that thing stick as straight possible into that hard rubber, eliminating something. I have not seen it yet, but you possibly could think that someone comes up with the idea and actually puts RTV sealant around it and glues this whole thing into place to these two hoses to basically seal this off. You could do it, but it will never work right. You're gonna lose your hair on this. So what they did now is, and that's a very well-known trick, is you remove these two bolts here. You disconnect the EHA valve, and you remove these two bolts, and then you're gonna see, then this is gonna come off basically. This is this part here from Bosch, which I took off, and you turn it around, and there's a screw. And when you take that screw loose, which you can't obviously anymore, you can see this on how this is stripped because the screw is frozen. Then there is a small Allen set screw in there, and you put, I think it's a 2mm, 3mm Allen key you put in there. And if you turn it clockwise, you will have the engine run richer, and if you turn it counterclockwise from the way I'm holding right now, then you're gonna have the engine run leaner. And this is basically a valve which circulates the oil, fuel between the upper and lower chamber through these three holes here, which have two little rubber, and they were actually in a good shape, O-rings on there. And what happens with this unit here too is there's also a spring internally in there which opens, which is the same principle as this here. All these units, basically these valves, work the same way. You apply a current and they will push something to close it, and then when you remove the current, then the spring is supposed to be pushing the thing back to be fully open. And these things get stuck, and this is the case here too. And then they start to mess around with this here. And then they get it to a point where they couldn't even open the screw. I couldn't open that screw. You can't even reach the set screw on this thing anymore. So this is a $600 part, which I got from Mercedes-Benz brand new, and I think I paid $450 for it. And that's how they combated it. So the rough idle was smoothened out with this here by setting the machine rich. Now I replaced this one here. This is still the old one I'm holding right now here, and it is running now lean. And then the other thing is, what they did is they went into here with the 3mm Allen key, and they basically pushed it down, and that adjusts this plate here. And when you adjust this, you can open the airflow up. There has to be a gap here. I forgot now what that is. It is in the Mercedes-Benz manual. And that clearance is usually set with this. And you go in there with the feeler gap all around. It has to have exactly the same clearance on all sides, all the way around it. But you can actually then open this up and help that to increase or decrease actually your idle speed once this thing here gets loose. I mean, this is a real dance on eggshells, and it is a real fiddle fucking to get this actually to work right. As you can see, there's quite some more work I gotta do. Now in the video which follows this one here, I forgot now what part this is gonna be here for our idle speed control issue. This will be the next one. Now I wanted to show you the other issue, just to give you an idea. This is the, before I'm gonna keep going. So this part was changed, these hoses were changed, EHA was changed, and the idle control valve was changed, and so was the 4-pin temperature sensor. And you can see this was actually broken off here. This is how brittle this stuff is. And you can see the discoloration on this. This is what that is. So this sits here, and that coolant water goes through it, and it goes to these other two sensors up here, which open up the vacuum, one at 50 degrees C, the other one at 80, I believe, or at 100, something around there, either one of the two. Now if you look at this here, this is the sensor I took out. For one, as you can see, the Mercedes start, it's an original one. I cleaned this off because you couldn't even read this. You can read now the part number. Then when you turn it over, it was VDO, made by VDO in Germany. It is your manufacturing date, 1989-03, M for manufacturing. Last one is the week. In this case, it is week 3. That would have been January of 1989. This is when this part was made. And even though it checks out electrically, what happens with these is that when they go through temperature changes, when the engine heats up, the resistance is not following this, what you actually have in the resistance chart in the manual, where you can see at 10 degrees, at 20 degrees Celsius, 30 degrees Celsius, that resistance, and so far and so on. That no longer works. So this was replaced here. This is the original part. It's 32 years old. We're like 4 weeks away from when this thing was made. Week 3, this is the 5 weeks away. 5-6 weeks ago, then it's going to be 32 years old. The thing is history. They messed around with it, they tested it, and actually what I found is that washer underneath here, there's a silver, I'm not quite sure what kind of metal that is, but it's a silver washer underneath here, and that was gone. And I got a new one, and this is now the new Mercedes-Benz replacement. And you can see this, the part number here is the 008 542 3217 INT for replacement. And if you look here, then you will see that this here is a 008 542 3217 Mercedes-Benz. And this one here is the Miley. This thing is now made in China. This is at least the stamp they put on here. Made in China. And this is now the substitute for this, what you get from the dealership. That's basically where this at. This is the latest one. It was like 29 bucks. I put it in, and it seems to be working fine. The other part we had a problem with is this here. Let me just see. This is all not that easy. The vacuum check valve, 3-way. The vacuum check valve, as you can see here, how pitted this is. See this? This thing here sits on the firewall. I don't know if you can see this. No, unfortunately, this is no longer in the picture. Here's the firewall coming around it. It would be about right here where my finger pointed into this black area. That's where this valve sits. And these two holes here, one goes to your storage vacuum tank for the air conditioning system for all these actuator valves inside the front there in your, what do you call it, the dashboard. And the other one is actually the one which goes to that distributor thing where you have your ACC unit controlling the electrically all these different valves, valve switches in there, and that's where the vacuum applies. And this thing actually, when everything is sealed in the air conditioning, it draws vacuum only once from the engine, and then it actually, when you turn the engine off, this locks the whole thing up and it stays under vacuum pretty much until doomsday. And this thing was leaking like there was no tomorrow. It was like grandma had gas from sauerkraut. I mean, that was just it. Again, this is another example of an original part, 32 years old. And these things go. I mean, at one point or another, it just goes. This was actually more expensive than the sensor. At 126 560SEL 78 MBZ original Mercedes-Benz part for this. Date of manufacturing 19, week 32, 2019. So that part is just about a year and a half old or so. Not quite that. It's a new one we got in there. So this is basically where it is at. So, I wanted to show you the EHA valve is the original Bosch valve, and this is the paperwork what comes with it. That means for your warranty and for everything what comes with it. See, this was originally printed in February 1989 for this. And it will tell you this in all languages. Let me just see where I got the box. Here's the box. Here it came in. This is your original part that is verified, tested. And the reason why these parts are so expensive for Mercedes-Benz is because they're basically selected, and they tell the manufacturer who makes the selected, tell Bosch. In this case, Bosch makes 1,000 of them. And Mercedes-Benz tells them, in order to get our label on there, you have to test them and they have to meet these tolerances and criteria and thresholds. And then out of 1,000 units Bosch built, they probably wind up sending 200 or 300 which meet the criteria over to Mercedes-Benz. But they paid for 1,000, so what they usually do is they scrap 700 of them, they go into the trash, or they used to at least. And the rest of them, the 200, 300, went to Mercedes-Benz. So that's why these parts are so expensive, because you're basically paying for what 1,000 parts or more cost them to make, for the few parts they actually get out of them to be usable. That's where that is coming from. The military usually does the same. If you're familiar with military equipment, that's the same process. And it looks okay. And if you electrically, like I said, it tests okay, but the spring is bad. It doesn't close off anymore. Plus, it has been tampered with. I mean, if you look at this bolt, that little screw in here, you cannot open it. It is completely frozen in there. And what I think is that these people did is they cross-threaded it when they put it back in there. And because it's a very fine thread going into this whole thing. Well, anyway, my other video now is a start when the engine was about 45, 50 degrees Celsius water temperature. Ambient temperature is about 43. And that's like in the middle range, which can cause quite some problems. I have not worked on the fuel system yet. I still have to change my fuel filter out from the 450SL to the correct one. I'm going to change the check valves on there, and I'm going to have to change the my accumulator there too, and then just do a pressure check. On my fuel regulator here, what you can see, fuel pressure regulator, that back hose broke off, so I have a new one coming. That is just a piece of rubber, and what you do is you're trying to pull out the old part which broke off and is inside there, and then you just put the new one in, and then you apply a vacuum to it, and that should move the diaphragm inside. They hardly go bad. That's another $500, $600 part, but that is easily recoverable. That is one of the very few parts which can actually be recovered. And you can see this here from all the work they did is they took out the holders for my spark plug wires, so I need to get new ones. And then I have to get the holders here for the fuel lines back into place. That is some of the things I need to do. The engine rattles, and the reason why that is because I have no more engine mounts left. I have the new engine mounts already and the transmission mount to be replaced, and I need to put a new flex disc in. The on my transmission, the what do you call it? The modulator has to be replaced. That is coming too, and I have to do a complete flush on the system as well. Otherwise, it runs pretty well. You will see what the thing is. Oh, and then I'm going to have to take the covers off, the camshaft covers on both sides. I've checked already the oil rails which run in here and spray the oil onto the camshaft. They're all okay. They're not going to go out very soon. But I have to double check my chain to see how much stretch I have and where my timing marks are and how the distributor is actually aligned or misaligned right now in terms of degrees with this, and that is part of the rough idle. So the bigger part is the missing or totally bad, gone engine mounts. That thing shakes, rattles, and rolls in there because it has nothing to sit on it. Then I have to check the shocks on those and see how the engine shocks are, to see on there if they're still good. The steering is good, brake is good, everything else is pretty good. And the entire AC system is operational, so we will get this thing going here pretty good. Any comments? I would be happy to see what people think about this. Otherwise, I'm quite curious to see on how many views we're actually going to get on this video. Otherwise, I will be posting probably 1 or 2 more videos this weekend. You will have, after this, the next video is going to be just a start, and you will see how fast the engine starts now and how nicely it idles. It's good. I'm pretty happy with this. We have to take into consideration that this engine has somewhere around 300,000 miles on it. There's no question about it. There's still probably here and there a couple vacuum leaks, small, tiny vacuum leaks, which I haven't fixed. I also have to do the EHA valve and the air pump. These are 2 things I haven't worried about it. The oxygen sensor is working, but the EHA valve is out, the diaphragm is blown. And the air pump, I'm not quite sure what the deal is, because that is really only something that comes into game when the engine is completely warm and to reduce emissions. That really has nothing to do with idling or warming up an engine, so it is more or less irrelevant. That is only in terms of performance and running the engine then at normal temperature when you drive to reduce the emissions. Literally, that's all there is to it. And then the other thing is, I'm going to get sorted out, what I didn't like too much yet, is the wires here. I didn't have to write wire gauge. This is 0.75 square millimeters. Wire which they use in the factory for this wiring harness, which goes back here into this tree and then from here over around it. Can you you get, this is the main harness here going around and coming back here. This is 0.75 square millimeter wire, and back there I have 0.35 square millimeters, or half of it. I'm gonna replace this, and then I'm gonna have to see what how I'm gonna restore that wiring harness to a better condition. That would be another thing. I also have the big rubber boot which sits underneath the whole CIS intake system here and seals this onto the throttle body housing. And I also have a new gasket for the throttle body housing. And at that point, when I get to that, to actually replace this, which is a pretty big job because you have to take this whole thing out, and this thing here sits on these kind of things, and they tend to break as soon as you turn them. You have the whole thing loose, basically, like this here. That's what they look. So this is kind of the projects which are coming. I will add this all to this series of videos under those part numbers. And like I said, the next one is the engine starting with these modifications and repairs I just described. And then we can take it from there on. And tomorrow I hope I can post a video with the old ICV where I can actually show on how this gets stuck, especially when you operate the current between 700, 600, 700 milliamps to 1 amp. You can nicely see on how the thing gets stuck, and then you push it with something and then it actually opens up all the way. You can then apply power again, it will then close, or trying to close. The closing works a little bit better. The problem is the opening. That's where that spring comes in. Okay, otherwise I wish everyone a good night, and I would like to thank everyone again for following me, and for all your views on the videos. Thank you.